Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Good afternoon. My name is Suzanne Miller. I'm a principal researcher here at the SEI, and today I'm joined with two colleagues that are actually in my own group. Shane Ficorilli, who is a software engineer in continuous deployment of capability, and our boss, our mutual boss, Hasan Yasar, who is the technical director of this directorate. So I want to welcome both of you. Today we're going to be talking about authority to operate, commonly known as ATO, and some of the things that are happening that are changing the landscape of how we secure our systems and software systems in the DoD. So before we get started with that topic, tell me a little bit about yourselves. Tell our listeners a little bit about what brought you to the SEI and this kind of work. Shane, why don't we start with you?
Sure. So I'm a DevSecOps engineer on, like you said, the continuous deployment of capability team, and I specialize in DevSecOps pipeline architecture and engineering. So one of my primary roles is working with our customers to help them make the right decisions whenever they're starting or to actually implement their DevSecOps pipelines.
What did you do that sort of led you into that kind of work?
So I come from an information systems background. So the blend of infrastructure as code, being able to automate the creation of virtual infrastructure was really the ultimate blend between being a sysadmin and kind of the development side as well.
Cool.
So I kind of found that perfect match.
Excellent. Hasan, tell us a little bit about your journey to the SEI and what brought you here.
It's a long journey.
I know, as I said, say a little bit.
So I have been at SEI almost 10 years. 2020 is good. I started 2010. Since that, I've been at SEI. Why I'm here at SEI or CMU, I had a lot of industry experience, and I would like to bring that industry experience to the different domains. Like not really doing the work, like really helping by knowing the challenges in software delivery, software deployment, and make sure that we are able to deploy and deliver any capabilities timely, and also with a security mindset as well. So as part of the CERT now, our idea of the DevOps idea started 6 years ago. Now it's getting more knowledgeable in terms of everybody wants to do. Now we have more challenge we have to do the work-wise, like what is the right way to the DevOps, what is the right way to DevSecOps and ATO. So one of the reasons I haven't continued here, because I would like to really help the communities. And Shane didn't say, actually, one thing I'm really happy that Shane have here as well. Before that, Shane was a security expert, actually, taking the class in the Heinz. And I said, Shane, we have to do more application side of it, because everybody's talking about the operational side.
Right.
But we have to do the security as why we are building application. That's the reason Shane is here. And he believed it on me.
Build security in, dude.
Yes, build security in and get that experience. Not really address security problem after the fact.
Sure.
Let's address security problem. Why we're building the systems. And ATO is one of them. How to do that.
So let's move into talking about authority to operate. So this is, for our DoD customers, this is a well-known attribute of any software system. I must have an authority to operate so that I can operate out in the field. And this is a process that has a whole lot of early acquisition, all the way through development, all the way into deployment kinds of activities. But historically, it's been applied to a single system. So if system A has an authority to operate, that's a different ATO than system B, than system C. And so what kind of problems does that style of ATO engender in the kind of ecosystem that we have today?
So I can start a little bit. And before diving to the problems, and I would like to a little bit open up to what ATO typically is. And almost every organizations, they have to approve the software before putting the production environment, regardless where they are in. Maybe the healthcare, maybe finance, everybody has to do that. With the specific context of the DoD, ATO is based on risk management framework. The organization has to follow
NIST.
up. Yeah, NIST 800-37, which is risk management framework they have to implement it. But how the information assurance person, which is the person is authorizing the application, will be pushed into the production environment, they are the manual process, which is a checklist. So what the checklist is based on, it is based on 800 53, which is NIST standards controllers. It's more than 1,000 controllers. So organization has to pick the right controllers and based on what they are looking for the application specific, and monitor every controllers before pushing the application to the
So these security controls are things that are different depending on the context of the application and the context of use. So there is quite a bit of work in figuring out what are the correct controls that are applicable to the system and applicable to the system in the context it's going to be used in.
Absolutely, like picking right controllers and also the monitor that which controller has been implemented in the life cycles. Not in just the testing phases like requirements or some organization to the threat modeling concept, how they get the threat modeling based on the controllers to the right mitigation strategies are. So it's really a manual process. How you select it, how you monitor it, and also how you approve that then.
Right.
So if there isn't any things process-wise, automations or traceabilities, it's becoming a bottleneck for multiple reasons. Bottleneck one, you cannot really deploy application on time. That will take sometimes 6 months, maybe a year. Second, you're going to spend a lot of time and money redo the work over and over and again. And third, the most important one, if there is any vulnerability that has been discovered in the production environment, how much you can quicker to update the patch on time, which is kind of addressing. It is because if it is delayed in the approval process, then if you're not able to update the production environment timely, it's becoming a vulnerable for the adversaries who will take an advantage of it any time. So that's a lot of challenges in that space.
So these kinds of problems, and one thing you didn't mention is, and by the way, if I decide that I need to change the system, then I also have to go through this process over again. I have to review all the controls, make sure they're still applicable, make sure that my mitigations are still relevant, et cetera, and then verify that they've actually. So that's, I think, one of the things that in the communities I work with, that idea that I have to freeze something and I can't allow it to change, even if my operational environment changes or my technology changes, that's a real barrier to us getting, our systems out to the speed of relevance, which is a theme that a lot of people are talking about. So I know that the community at large has come up with this idea of a continuous ATO, continuous authority to operate. So this is a different way of approaching that whole problem. And Shane, why don't you describe for us, what is it that is different about a continuous ATO from a traditional ATO?
So traditionally, as Hasan had said before, that the approval process had often, taken place at the very end of, your software development lifecycle, right before you would actually deploy to either your staging or production, and that would be a manual process. So with continuous ATO, what we're trying to do is to have that process take place throughout the development lifecycle, specifically at the continuous integration phase. And originally that manual approval process really helped to reinforce the waterfall style of delivery, where with approving and checking against the risk management frameworks continuously as you're iteratively developing helps to develop value at the speed of relevance, like you had said, because it's happening as you're developing instead of at the very end before deployment.
And so it supports the iterative, agile development processes that are being emphasized in DoD right now. Okay.
One of the challenges that we were talking at the beginning, why it takes time as manually, because we have to go through all the dependencies of the things we are building. Dependencies, and which is all the libraries, all the infrastructure pieces, and has to be taken and looking over and over and again. Versus when we look at the application delivery or application building process, we are writing a very small set of code, but we are spending a lot of time recheck the back again, which has been done already at the past. Since we don't have a traceability of backend components, then how much we looked at, how much we review and approve it, we go back again to the manual and manual again. So what we are seeing with continuous, we have already done some of the preliminary dependencies as has been approved already. Maybe some other dependents, maybe some services. So just to get an approval, only the code pieces, which is a very small pieces, and approved. But what other artifacts are generated artifacts through the pipeline, like using a continuous integration, continuous deployment pipeline, then we'll generate the right artifacts to the organization, or the information resource person will approve only the changes has been made, not everything else. That's the beauty of the continuous process.
So there's an assumption here that we've got a stable infrastructure and that we understand it well enough to instrument it so that we can determine if there have been changes to it, right? Those are some assumptions that we're making. And these are assumptions that are actually pretty easy to fulfill in our cloud environments and in our modern kind of deployment, development environments, not deployment, but our modern development environments. It's actually feasible for us to do that. And so that's one of the things that has shifted, I'd say, in the last 10 years that makes this idea even feasible to consider.
That's right.
So when we think about continuous ATO and where it is now, where are you seeing this being applied that you can talk about, and what are some of the challenges to getting this idea accepted within communities for whom it would have relevance?
So I can, if you want one challenge, which is a typical challenges, I'm sure you can dive in more technical side, Shane. First one is a cultural.
I knew you were going to say
that. I know that, right?
I know. Hasan and I
it
talk about cultural issues all the time, so this is a common conversation.
It's a belief, right? The culture is, and security person or information person has to believe that trust the developers or trust other components. We don't have that trust capability yet, because there is kind of like a conflict between each other. So because I don't know, then I don't trust you.
I didn't do it myself.
I didn't do it myself, and I have to look at it. I have to really touch it. I have to feel it. It's a culture problem. But how to enable the issues, like make sure that we're going to trust each other, it's a learning curve. It's like a journey, like sharing all the artifacts, building the trust relationship between the secret expert with the developers, building the trust relationship between human and the machine itself.
Right.
Then other things like if the system is generating a lot of positive, and person will be looking around on what I'm going to decide, and now if person is take a risk and will approve the systems, like if something happens, am I going to lose my job? Or something happened to me, maybe it's going to cause so much other problems in the organization. What will happen? So it's creating a fear. Now the fear is not sometimes in the bad case, but sometimes causing like what I'm going to do next, which is blocking. So it's like all creating a cascaded effect, not trust, creating a fear, and creating problem. It's all awareness of the cultural level of,
There's an aspect as well that people tend to self-select into roles that they're comfortable with, and there is a risk-averse aspect to security, right? That's really, security is the epitome of risk aversion. Definition, right? It's how do I avoid risk is what my security is about. So the people that are going to self-select into that role are not naturally going to be trusting. And so we have to do more than might be typical with just a developer to actually engender that trust. So what are some of the aspects of the continuous ATO process that have evolved to actually help with that?
The first things what I did for that cultural elements, I brought the secret expert and developer into the same room. Let them talk. And share the ideas or share the bottleneck, share the problems, what they see, building the trust in a human level. So, and when the developer are generating some artifacts, and IA person will trust the artifacts because they see they're in the same boat and they're in the same goals and they're sharing, which is bring the same room. Then tooling aspect, which Shane is going to cover a problem or tooling side of it, how to do it, and also depends on the tooling process as well, like in the infrastructure pieces and deployment pipeline that can be done.
So Shane, what are some of the things that have evolved as these are strategies that help the security, the sort of risk-averse security community trust that the infrastructure is going to remain less vulnerable, that the applications are going to get the attention they deserve? How does the tooling side help with that?
So I would say that one of the biggest factors that really allow for continuous ATO to take place is the creation of all of your environments through infrastructure as code. That really helps both people on the operations side, the security side, and developers to get an environment in a scripted way that can be approved as code. So then you're actually able to say, not only are these specific environments approved for deployment, but we know exactly what versions of software are going to be in those environments because they're defined and stored in source control.
And for those of our listeners that aren't familiar with that particular concept, give us 50 seconds on not 52, not 55, but 50 seconds on what is infrastructure as code.
So infrastructure as code is basically different types of scripted languages that allow for the virtual creation of infrastructure across various platforms. So you can create anything from containers to virtual machines to any type of infrastructure in any cloud providers such as like AWS or in Azure. Pretty much any type of virtual infrastructure that normally would be created in a manual process, you can write scripts as code and version control those to be able to recreate environments on demand.
So that control, that version control, that assuring of I'm not going to be able to change this, or that you aren't going to be able to change this just because you feel like it. That's one of the things that gives the security community a little bit more faith that this is a safe thing to do.
Absolutely.
Yeah. When it's in infrastructure, it's not just the operating systems.
Right.
It is also what tools or what the libraries is to require the application run. All the application dependencies, all the application configuration is also part of the infrastructure code pieces too.
And my understanding is that you also eliminate things that are not needed. So
That's
one of
right.
the big issues in the security community is, we fondly call dead code, code that just is just there and is not doing anything and creates a vulnerability because of its existence and possibility that it can interact with other elements of the infrastructure. So this infrastructure as code actually eliminates one of those risks in many environments.
Eliminate, and also it's going to create a traceabilities, and also it's going to create an inventory mechanism. It's going to create a transparency. So going back to our cultural problem we talked about at the beginning, IA person knows exactly what the developers needs to write, what the developers needs to run application, which is in the code itself. Not giving a piece of paper says, here is my dependencies,
Here's my proof.
and then follow it, and it's going to run an environment. No, instead of say, here's my script, run it. Then the IA person exactly knows that application is calling here and there and connecting this dot, connecting here, downloading that application or dependencies. They have a full visibilities. That's how trust starts from the visibilities at the beginning.
Transparency
Right.
is one of the big
absolutely.
things. And the other thing that you haven't mentioned, though, is that the speed at which I can repeat this process is so different than provisioning infrastructure from a manual viewpoint. And so that ability, if for some reason the security person has some doubt about whether this version was provisioned correctly, they can just run it again and do compares and things like that. So that ability to pretty much on demand re-provision and restart from scratch, that's something that in a manual
no way.
environment,
It could never take place.
Oh my gosh, you'd be here all weekend, and that's people won't do that.
That's kind of like assurances for risk-aware person.
Yeah.
Will be guaranteed that I have a fully automated and fully repeatable environments. If something happens, just changing one of the libraries and repush again. So, which is guaranteed to person. Yes, there is a risk probably, but if something happens, I'm able to change infrastructure, all the
It's
dependencies,
resilience.
anytime if I need to.
Yeah, so that resilience of being able to recover from, and not just from the viewpoint of if something doesn't kind of feel right, it's also from the viewpoint of if a vulnerability is identified, I can swap the vulnerable element out for something that I have trust in and continue operating. So this has huge implications for our operational environments and our ability to deploy in speed of relevance. When we have changes in operational environments and technology, we need to pivot in areas like that. Are there any particular success stories that you want to point to that help people to understand just how much effect this has had on the community?
I'm going to respond in different ways, Susie. Instead of saying a success stories, I will give many examples. They don't have right mindset infrastructure component or not a continuous ATO. They are failing miserably.
Okay, so what are the failure modes that if you don't do this,
if you go to any security news pages or any type of news organizations, you will see a lot of data breaches happening.
Right.
And these people are mainly lack of not implementing proper infrastructure behind the scenes. Equifax is one of them. Or many other data breaches is not having right infrastructure management or not dependency management on it. In AWS cases happened recently, or Capital One happened recently. There are many examples are leading us. It is not properly vetted in their process, and like not able to keep trace any key management in their code itself, not able to manage the software delivery deployment pipeline, who is touching, who's changing, or not able to find out all the dependencies in their build process, kind of like ad hoc developer are pulling here and there. Even though some organization, they don't know anything running in the infrastructures as OpenSSL, an example. Like when OpenSSL heartbeat problem arose around 2013, and a lot of organization had no idea they were using OpenSSL or not. So there are bad stories, because we don't hear the good stories because they're doing great. So
well, there is
hear
that.
about the bad ones, so bad ones is affecting our life if we look at it.
So this is actually a call to say continuous ATO is something that commercial organizations, even if you're not subject to the same kind of regulations that we are in DoD, this is something you should be thinking about.
I completely agree. And when we look at this at the beginning of the course, approval depends on which organization you are in. If organization are in healthcare industry, they have to follow up the HIPAA requirements, which is requiring a certain security control has to be implemented. Financial sector has the Sarbanes-Oxley. They have to implement that controllers. Or furthermore, the GDPR, if you look at the GDPR requirements, we have to do similar things, find out how we are handling the data. Somebody has to be in approval process. So in DoD context, we are saying ATO, but industry is doing the similar things. But the foundational technology is helping to achieve, which is DevSecOps is helping, or DevOps is helping to achieve that goals as building up right infrastructure, building automation.
So we've got DevOps, which is now a very familiar term to everyone, but you've just started talking about, and we've been talking at the SEI about DevSecOps. And so talk about for a minute about how does DevSecOps relate to this continuous ATO process?
So I would say that DevSecOps is really just DevOps done correctly. So with DevSecOps,
now you're throwing down the gauntlet.
So, with DevOps, you're really automating your deployment and delivery pipeline. You're taking advantage of a lot of the automated testing that takes place within the continuous integration phase. But with DevSecOps, you're now taking advantage of all of the security automation that you can incorporate throughout that pipeline.
All right.
So from anything from automating static code analysis to automating the checking of vulnerabilities in your third-party dependencies to doing automated container image scans or automated dynamic analysis testing. So you're basically just adding that additional layer of security automation into your deployment pipeline, which is something that should have been automated from the beginning anyway. So that's why I said it's really just DevOps done correctly.
Yeah, that's true, but because organizations are not feeling as necessary using a security activities, it's kind of not intentionally, but it is not bringing money to the organization as a value. We forgot or we ignored at the security.
It's what we sometimes call a hygiene activity. It's make sure you remember to brush your teeth, but it's not something that is going to make you look better. It's not like wearing a new suit or anything.
That's when we have to call out security. Clearly has to be part of it. Has to be part of throughout the life cycle, not only having a static analysis, not just having a dynamic analysis. Has to be throughout the life cycle. Really from the beginning all the way to the end. That's the way we can achieve the continuous ATO. That's the way we can achieve the selecting right controllers based on my requirements and implementing during the life cycle and trace that the requirement has been properly implemented in the life cycle, which is kind of very connected to the life cycle, which activities is part of the overall ATO process.
Okay. All right. Anything that we haven't talked about that you wanted to make sure our listeners know about continuous ATO and DevSecOps, what things are going on here at the SEI?
So in a couple of things I would like to mention as well with the DevSecOps and ATO, the continuous ATO, that can be achieved through DevSecOps only. If the organization are looking for to implement continuous ATO, they have to have a great DevOps or DevSecOps environment in terms of the traceability pipeline. Then all the stakeholders, which we have a diagram actually through the SEI website, and that can be used as a map, as the kind of layout, what needs to be done, in which stage we have to do. We don't want to go over every steps, but I really encourage any people take a look and then download a kind of overall posters. Then think about building up the pipeline, get all the stakeholders together. That's how we can achieve the cultural issues and enable that. And also the building a right process into that environment. Like, how are we going to build up increment iterative development? If we are building a great environment, then having an ATO just environment pieces. But if you are building a bigger monolithic application in the pipeline, we're not going to have the continuous ATO.
Right.
We would like to have a quick build based on dependencies. So as the SEI, we have been helping for the DoD building up the containerization and the overall DoD-wide containerization concept. Then DoD or anybody will able to pull up the hardened containers, putting in their application has been authorized and approved already.
Right.
Yep.
So this idea is going beyond an individual infrastructure. That's the thing that we're seeing is looking at this from an enterprise, from a DoD
Absolutely.
enterprise viewpoint of saying everybody needs hardened containers.
Right.
What are the things everybody needs no matter what you're doing, and where you're looking for the sort of customization being the exception rather than the rule.
Correct.
As one of the ways that we're able to help people to move through this more quickly.
Right.
So that's important. And then this idea of culture, but the other aspect that I get into when I talk to people about this is governance. That's an aspect not just of your culture, but of your process of how do we make the decisions that something is okay, something is not okay? Who makes those decisions? Those are some of the stakeholders you're talking about.
That's right.
And making sure that the people who can say no are part of the process of understanding how do we say yes.
Right.
And so that's one of the, I think, areas that the SEI is a little bit more conscious of when we go in to talk to organizations than some of your, sort of DevOps tool vendors, because we know that if you can say no, I have to figure out how to get you, what makes you comfortable saying yes. And those are some of the things that I know we've run into in some of the customers that we've worked with.
Right.
So what's in the future? What are the things coming up that you're just itching to get into that, we're still dealing with other things, but what are some of the future things that you think are going to be coming along with continuous ATOs and DevSecOps?
Shane, you want to chime in? Or
Sure.
What do you want to fix? What's left out there for you to fix, Shane?
a lot we can fix it.
So I think the idea of using hardened container images kind of from the get-go is really starting to catch on, and I think the fact that the DoD is taking it upon themselves to provide a repository or a registry of hardened images for all of the different services to use is really going to help to solve a lot of issues for vulnerable dependency usage within your infrastructure right away. I would like to see the community adopting that, kind of in general, using hardened containers, but it is difficult to create basically a worldwide registry of hardened containers.
Sure.
It's a lot more difficult than it may seem. So,
Well, we've got legacy systems to deal with, and that's
right.
adds a wrench into this
Absolutely.
whole works. There's things that you look at and you go, not really worth building a container around, but at the same time, not sure that I want to let it out in the wild in its own state. So there's some of that I know is something that we deal with on a regular basis.
Mm-hmm. And I know one of the other things that we've seen too is that within DoD, a lot of organizations are really trying to tackle the challenge of decomposing their huge monolith applications into microservices. So using something like a strangler pattern or kind of chiseling away at their big monolith one service at a time, and it's really been really cool to see them undergo that challenge.
I mean, there's been an evolution in processing. When I was developing stuff in the 80s, we had so many resource constraints that an awful lot of these systems from that era are very tightly coupled because we just didn't have room to have external APIs. We didn't have enough computing resources, or storage, or memory, and so we did a lot to get the performance we needed. Well, now we're reaping the effects of that because now we've got all these things that are intertwined like spaghetti, and we have to disentangle them so that we can actually understand we have room now. So now how do we actually make it so that we can see what's there and deal with things? This needs to be containerized. This needs to go away altogether. I mean, that's a whole set of challenges that I know many of my customers are dealing with right now.
Mm-hmm. And other challenges, we would like to work actually specific, more hardware-based systems. Mm-hmm. If we look at the current tooling schema. It's more about the web application sense.
Right.
But we would like to spend more time building the right process, right concept with the right tooling that will help the organization build up embedded systems or the hardware pieces or building the firmware on it. Right. Or how can we build up a modularity in the firmware level or the hardware level so we have a continuous process, continuous integration delivery.
Right.
I call it continuous security. That will help us to build up a continuous ATO overall process. It's another exciting word. We would like to continue work and explore the ideas.
So you're going to be busy for a while. Nobody gets to retire in the near term.
There's a lot of work to do for everybody.
There is.
We have a lot of challenges, complexity, dependency. Since it's like we are living in a very connected world, we have a lot of hardware that depends on the software. Now we have different layers of applications, different layers of tools, and it's just giving so much. I don't want to say problem, more about the complexity we have to solve that.
Well, we're moving from complicated to complex, right?
That's right.
Complicated where we know what the scope of the problem is, and so it may be difficult to manage through it, but we know what it is. Complex, sometimes we don't even know what the scope of the problem is. We can't see all the elements, and that's, I think, what you're referring to is we can't see everything the way we used to.
That's right.
And so we have to find new ways to figure out how to deal with that.
We are living in a dependent world right now. Like very basic web application. If you look at it, now there are more than 25 dependencies as a layer-wise in building up a single web applications versus in the 30 years ago when I write a hello world in the C++.
We had the 7-layer OSI model. That was it.
Right.
7 seemed like so many at the time.
In application, many frameworks needs to be done. Many dependencies we don't know what is really behind it. If you don't know that's going to be like, you don't estimate what the complexity, what the dependency are.
Right. Well, I want to thank both of you for joining us today and talking about this important issue. I think not only are the military folks nodding their heads up and down, I hope we got the attention, some of the folks out in the commercial industry as well. We do have transcripts that will be available for this that will include links to resources. There are a lot of resources related to this, both blog posts, other podcasts. So we want to make sure courses, those will be attached to the podcast. And I thank all of our listeners for viewing this today. And thank you again for joining us.
Thanks for having us. Thank you.
Thanks for having us.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.